Okay, so let's take a look at this linear system. Yesterday, quick review, we talked about how we could find a solution to the linear system graphically, right? Let's go ahead and close all the Chromebooks for just a second. You'll get to open those up and use them pretty quick. What if we don't have access to graphing technology, though, and so we can't find the intersection? Then we've got to do this algebraically, right? So what methods are options for us algebraically? What are the two ways we can solve a linear system using algebra instead of graphing? Which one? Substitution. Okay, good. So that's one possibility. And then the other one is elimination. Okay, so when is substitution a viable option for us? When could we use it? Okay, when we can easily isolate one of the variables, right? Which means, essentially what that means is the coefficient of one of the variables in one of the equations is either 1 or -1, okay? Go ahead and close that up, please. So in this case, is there a variable that's easy to isolate?
Oh, yeah, X.
Okay, X in the bottom, right? This guy right here would be pretty easy to isolate, right? Now, how could we do that? Think about the steps to get that X by itself.
Add X and subtract 1.
Oh, good. That's the best way to do it. A lot of times the way that people will think about this is they'll want to push the 6y to that side and then multiply or divide by -1. That's fine. It works. But to me, it's easier to move things around by adding and subtracting than it is to multiply and divide. And you can do it all in one step. Think about this equation right here. If we've got -x minus 6y equals 1, would you agree it doesn't really matter which side the x ends up on when I isolate it? Right? I could always, let's say the x ends up on the right side, I can always just flip that around, right? That's no big deal. So we could do two things at once here. We want to get the x by itself. Well, it's negative. Well, why don't I add the x to this side, which is going to make it positive, right? And then while I'm doing it, if I want to get the x by itself, this term right here, I could just push over to this side by subtracting 1 from both sides. Do it all in one fell swoop, right? So we end up with what then if we do that stuff? We're going to get the x on one side, which is equal to what? I got my -6y. What? -1, yeah. So x equals -6y minus 1. We're going to put a box around it because that's our substitution equation, right? That's important. Okay, and then okay, now what? So we've got our substitution equation. We found that from the second equation, right? We isolated x in the second equation. So what do we do with the substitution equation then? Plug it back into which equation? The top one, the other one, right? Whichever one we use to isolate x, we're going to plug it into the other one. So now, this stuff right here that x is equal to, we're going to plug into the top equation, right? So what's that look like then? The top equation is going to become 2 times x, but x is actually, yeah, good, negative 6y minus 1 minus 5y equals -2, right? That's easy to solve, though. I've got a single equation now with only one variable. That's a piece of cake. What are the steps I'd go through to solve this? What would I probably do first? Distribute. I see, that's the distribution side. I know what you mean. So we're going to distribute the 2 to both places. So 2 times -6y is?
-12y.
2 times -1?
Negative.
Good, and then I've got a minus 5y and a -2. Now what?
Combine like terms.
Combine like terms. -12y combined with -5y is? Good. -2 equals Negative 2. Add 2 to both sides. Good. So if I add 2 to both sides, I get negative 17y equals 0. So now what?
I add 17.
Nah, can't add. What?
Divide.
Divide. Good, because y is being multiplied by negative 17. So I undo that by dividing, right? Good. And so I end up with y by itself. 0 divided by anything is
0.
0.
Y equals 0.
Good. So y equals 0. So we're halfway there. Now, where do I go to find x? Yeah, in fact, I've already got the substitution equation is perfectly set up for that, right?
X negative 1.
All I got to do is plug it in there, and I'm going to get x. Good. So if we plug y equals 0 back in to there, what do we get? Well, then we just get x equals negative 6 times 0 minus 1, which is negative 1, right? Okay. And so then if I combine both parts of my solution into an ordered pair, which is how we do it, I just get the ordered pair negative 1, 0, right? What's the significance of that point if we were going to graph these things?
It's on the...
Okay, well, that's the sign for intersection. There you go. It's the intersection of the two lines, right? Okay, how could I check to see if I'm correct algebraically? Good, I could plug them in. Good. So let's try that. If I plug them into this top equation up here, what am I going to get? Let's see. I get, let me just copy that. Come down here so we can try this out, see if it works. Oops. Okay, so the top one gives us, if we plug it in, I get 2 times negative 1 minus 5 times 0 equals negative 2. True or false? Yeah, it's true, isn't it? Right? Check. Are we done? Did we check it? Is that good enough? Not quite. You got to check it in the other equation too, because remember, the solution of a system has to work in both equations, right? So I'd also have to go down and check this down here. Negative 1. What's that? 1. Good. Minus 6 times 0 equals 1. That's true, isn't it? So it checks in both equations, so we know it's correct. Okay? All right. Good stuff. And once again, that was a good candidate for substitution because it was easy to get that x by itself. Is that a good candidate for substitution?
No.
No. It turns out it actually would work accidentally, just because when I reduce the fractions, the denominators would go away. But in general, if I don't have coefficients of 1 or negative 1, I don't want to use substitution, right? Because I'm likely to get fractions that I have to work with, and I don't want to do that, right? So this is where elimination comes in. Okay, so what's our goal with elimination? Do you remember this? Elimination is about eliminating one of the variables, right? Let's look at what happens right now if I add these up. Would you agree, this is, the fancy word for this is called the principle of linear superposition. Do not need to know that. If I have equations, think about it this way. If I have equations, if the left side equals the right side of both equations, couldn't I add the left side of this equation to the left side of that equation, and it should equal the sum of the right sides? Because they're equal, right? Does that make sense? Okay. Think of it this way. If I have a pound of, I don't know, of steel in this hand, and I have a pound of sand in this hand, and I add that to 2 pounds of steel and 2 pounds of sand, I'm going to still get 3 pounds of steel and 3 pounds of sand, right? If I add those up, agreed? Okay. So if I add these up this time, if I add up these two equations, I've got them in standard form. So I've got each column is going to be a sum of like terms. X is added with x's, y's with y's, etc. Right? 6x plus negative 3x is what? 3x. 12y plus 3y is then negative 48 and negative 21.
That's just, that's my.
Okay, negative 69. So did that help us? Not really, because none of the variables dropped out, right? We didn't eliminate anything, so that didn't really work very well, right? What do we have to do to make it work, though, so at least one of those variables is going to cancel out?
Make it the opposite, right?
Got to make it the opposite. Like if I were adding 6 plus negative 6, that would have worked great. Then the x's would have canceled, right? So to do that, I'm going to multiply the bottom equation by what? 2. I'm going to distribute a 2 through both sides. So the way I show this is I draw an arrow with whatever the value I'm going to distribute just goes in the bubble in the middle of the arrow. The top one we don't have to do anything to, do we? So we can just leave that arrow, we're just going to move that equation over here as it is, not changing anything. So the top one is still 6x plus 12y equals negative 48. If I distribute a 2 through the bottom, what do I get? Keep going.
6.
Good, plus 6y. Good. Keep going. Equals.
Negative 42.
Good. Negative 42. Okay, so we'll add those up. If I add those up, now this is good. Look, the x's are eliminated. They cancel, right? So we end up then with just, what's the sum of this column?
18.
Good. Equals. Good. Negative 90. I can isolate y by dividing both sides through by 18, right? So what do I get then? What's 90 divided by positive 18? Negative 90 divided by positive 18. Negative 5. Okay, halfway there, right? Now what?
Plug it back in.
Plug it back in to either one, whichever one seems more convenient of the original equations. It doesn't make any difference. How about if we plug it into the second one because the coefficients are a little bit smaller, right? So then the second equation would become negative 3x plus 3 times negative 5, because that's my y value, equals negative 21, right? And that's easy to solve for. Now I've got a single x there, no big deal, right? So
How do you cancel out the 2 though, times
okay, meaning, why didn't I plug it back into this equation? I could. It would be fine, but I don't need to because these are bigger coefficients, right? So I'd rather not. When I distribute a 2 through, I'm distributing it through to everything, right? So I'm not really changing. What would that do to the line if I graphed it? Nothing. It'd look exactly the same, right?
Okay.
It's just a more convenient way to write it so the x's cancel.
Gotcha.
Does that answer your question?
Yeah.
Okay. So negative 3x, that's going to be what, minus 15 equals negative 21. 2 steps in order to isolate x. Add 15.
Divide by 3.
Divide by negative 3. Good. So I get negative 3x equals, what, negative 6, right? Divide by negative 3 and get what? 2. So there's my solution then, right? I've got the ordered pair, x is 2, y is negative 5.
Plug it back in.
And we could plug it back in, right? On a test, we'd plug those back in for sure and see if we did it right before we hit submit. Okay? What's the difference with this one? We don't even have to do the whole problem, but which method am I clearly going to use here? Elimination or substitution?
Elimination.
Elimination,
Yeah.
right? Okay. Okay, so if I'm going to use elimination, this time I can't just multiply one equation by something, can I? What am I going to do here? Multiply them both. And there's a infinite number of ways I could make this work, but I want to pick the easiest. I want to multiply by the smallest possible numbers, right? So what do you think? Because now let's look at both of these columns for a second, right? I've got to make either the x's or the y's cancel. And to make the x's cancel, I would have to multiply so I get a common multiple of 6 and 5, right?
6 on the bottom and 5 on the
6 on the bottom, 5 on the top. I could get 30, right? And make one of them negative and one positive, just so it makes sure I get numbers that cancel, right? What about the y's? There's no common multiple of 9 and 10 other than 90, right? So which one should I probably do? Smaller one. Let's do the x's, right? So if we multiply you tell me, multiply the top by what? 5, okay?
Makes it positives.
Then that's going to give me, let's go ahead and distribute that through so we see what we get. What is that? Negative 30x
45.
equals, you can do this. Don't give up on this. You can do this. Here's a little mental math, right? We could just say 5 times 144. We know it's going to be negative, but let's just focus on what the number's going to be. Let's break it into parts. 5 times 100 is 500. 5 times 40 is, you can do it,
200.
200. So that's 500 and 200 is 700, right? 5 times 4? 20. So 720, right? No big deal. You can do that.
Oh, it's not common units.
Yes, you are. So what do we multiply the bottom by? What do we need to get for my x value? Positive 30. So what are we going to multiply by then? Negative 6. Good. We need to multiply by a negative to change that negative to a positive, right? So that's going to give us positive 30x, and that's a negative 6. So what am I going to get there?
Negative 60y.
Good. Negative 60y. And then negative 6 times 55. Well, what's 6 times 50? Yeah, 300. 6 times 5? 30. So 330. And negative? Okay, so if we add those up, the x's cancel. Negative 45y combined with negative 60y is negative.
Is it still negative?
Yeah, oh yeah, because it's negative plus negative is negative, right? Negative 105y, good. Negative 720 plus negative 330,
1,050.
good. And so now if I divide each side by negative 105, what do we get?
945.
So 1,050 divided by 105, I've just got an extra 0 there, don't I? These cancel to 1, but then there's a 0, so I just get negative 10. Right? Okay, so anyway, you could take it from there, right? Now all I'd have to do is go plug that into one of the two equations and solve for x. Okay? What happens, I don't want to spend a lot of time on this, but what happens if I do this process of elimination or substitution and the answer I get is something like 10 equals 10? What's that tell us? When I do all this stuff, instead of getting something like y equals negative 10, both the variables cancel.
Same line.
Same line. It's always, because how often is that true? Is 10 equal to 10? Always, right? So that corresponds to an infinite number of solutions. So that would be same line. What if instead I got something like, so that's same line, or in Moodle that would be infinitely many. What if I get the answer like 0 equals 5?
No solution.
No solutions. That's never true, right? No solutions. So in Moodle, on most of those questions, I think you have to put in NS. Okay? Make sense? I think these are really old questions, and I think some of the ones that want you to put in IM are not working. So I'll fix them. It's easy to fix. I'll fix those at lunch today. All you have to do on those is when you go to those problems where you think you get an IM, if you just reload the question, it'll give you one that'll work then. Okay? Does that make sense? Okay? All right, last issue. What about, what was the one I wanted to do? It wasn't even really this one. There was another one. Oh, I know what it was. I know what it was. Here, let me grab one of these. I saw that people were having a tough time, and I looked at how people were doing on these assignments. This is what most people were having trouble with. Let's see. think it was practice 3. No. Yeah. Is this it? Yeah. Something like that, but I want to do instead. No. No. Darn it. There we go. Let's do it like that. There's just one small mistake people are making on this. I can see what they're doing.
You have to
Not everybody, but
put it in,
standard form.
yeah.
Yeah. Okay. So that, yeah, a lot of people are having trouble with that. So if we want to take this line and we want to write it in slope, oh, hang on, this one says write it in slope-intercept form. What if we instead, because one of these they want you to write it in standard form. That's the one I want. Write it in standard form. Okay, so it's probably easiest to start off in slope-intercept form, right? Okay, so what's the slope of this line?
Like,
So I'm going up by how much?
5.
By 1, 2, 3, 4, right? So that's my rise, and my run is 5. So the slope is positive 4/5. What's the y-intercept?
1.
1. Okay. Everybody see that? Crossing the y-axis at 1. So that tells me then that the line is y equals 4/5 x plus 1. If they want that in standard form, though, I got to tweak that around a little bit, right? What do I do? What are the rules for standard form? And standard form means it's going to look like this, right? AX plus BY equals C. What can you tell me about A, B, and C? What are the rules for standard form? So A, B, and C must all be what? Can they be fractions? No. They're integers, positive or negative whole numbers, right? So that's one rule. And there's something else. What about A? What's true for A? It has to be an integer, but it also has to be positive. So A has to be greater than 0. Okay? All right, so then how am I going to get rid of that fraction, first of all? How do I clear fractions from an equation? What do I do? Multiply by 5, right? Good. So I'm going to multiply each side by 5, okay? 5 times y is 5y. If I distribute the 5 here, when I'm clearing fractions, 5 over 5 is what? 1, okay? And so I end up with 1 times 4 is 4x, right? And then if I distribute the 5 to the 1, I just get a 5, right? Everybody agree? Okay, so now when I put the 4x on this side, let's say I do it that way. Let's say I subtract 4x from both sides. Then I'm going to get a negative 4x plus 5y. Let's put the x term first, right? Equals positive 5. That's where a lot of people leave it. Why is that wrong?
Because the first number is
Because a is negative. So all I have to do to make a positive is multiply both sides by what? Negative 1. Which just means change the signs of everything, right? So then this first one is going to become positive 4x minus 5y equals negative 5. Good. That would be our answer. Okay? Make sense? Okay. Work. I'll let you work.